Yes, hello friends, welcome to RIPOSE lectures. Today we're going to talk about a multi-fluid manometer. In this video, we're going to talk about how to measure pressure with a multi-fluid manometer. So what is a multi-fluid manometer? A multi-fluid manometer is a manometer which has many liquids. From the word multi means many. So that means there are many liquids. You have oil, then we have water, then we have mercury. We have three liquids, multi-liquids. We have water, oil, and mercury. So we're going to analyze this. Follow very well this video. Let's analyze it. We are going to form what we call the manometer equation for. We are going to form what we call the manometer equation. We are going to form what we call what? The manometer equation for the multi-fluid manometer. We said a multi-fluid manometer is a manometer which is having many fluids. For example, water, oil, and mercury. We have many fluids. So let's calculate it. Let's write the manometer equation. In our next video, I shall show you how to calculate solutions using the manometer equation. Let's calculate it. We have 2 points. We have this side is my left side, their side is the right hand side. This side is the left, this side is the what? The right. When analyzing, you can either use the left side or the right hand side. So let's use the left hand side to analyze this. Let's begin. Left hand side, we are at point 1. So point 1 is what? Air. So in point 1, we are going to begin from what? Point 1. So the pressure at point 1 is P1. We are going to say P1, that's the pressure at point 1. So when analyzing manometer, if you are moving down, the pressure is positive. If you are moving up, the pressure is negative. Why? Because when you are moving down, the pressure in liquids increases with depth. That means when you're moving down, the pressure increases, so you add. When I'm moving up, the pressure reduces. That is what you subtract. That is what? Negative. Let's see. From point 1, as we move down to this point here, we find that our height is what? H1. So what's the pressure? The pressure in liquids, first of all, must know that P is same as H density times G. So the pressure in liquid depends on the height of the water column, the density of the water, then the action due to what? To gravity. So when we want to get the pressure due to this height H1, it will be downwards. So we're moving what? Down. So when we're moving down is what? Positive. So it's going to be what? Plus, because we're moving down. So this is going to be H is what? H1. It's going to be H1 times the density. This is water. So it's going to be density of water times G. That's very important. Now after I finish this point and this point down the same level. Since this point and this point on the same level, therefore you jump because the pressure on the same level is the same. Meaning the pressure at this point is the same as the pressure at this point. So you jump from this point to this point. So there's no need of calculating the pressure down here because the pressure at this point are the same. So after this point, still the pressure at this point here is the same as the pressure at this point because they're on the same level. When the pressure is on the same level, that's the pressure are the same. So that means when you reach this point here, you move where? Down. When you move down is what? Positive. Because the pressure increases as you move what? Downwards. When you move upward, it is what? Negative. Because the pressure reduces as you move what? Upwards. So when you move downwards, you're going to add. It's going to be plus. This is what? Oil. All this from here up to here is what? Oil. So it's going to be H2. The height of the oil column is what? H2. Times the density of the what? The oil, which is density of the what? Oil, times G. G stands for the acceleration due to gravity. Now, after reaching this point here, we are going to what? Again jump. Why? Because the pressure at this point is the same as the pressure what? At that point. So when the pressure at this point is the same as the pressure point, so we just what? Jump from this point to this point. We don't calculate the pressure down here. We just jump from this point to this point. After reaching this point here, then we move where? up. We say when I'm moving up, we what? We subtract. When I'm moving downwards, we add, because the pressure in liquids increases as you move down. So when I move down, it is positive. When I move up, is negative. So we are moving up. So it's going to be what? Negative. So we are at this point, it's going to go up. So it's going to be density of mercury, because this is what? Mercury. But height is what? H3. So since I'm moving upwards to go to point 2, it's going to be what? Negative. Then we say H what? H3. From our formula here, we say the pressure depends on H, density times what? G. So it's going to be H3 times the density of mercury, which is what? Density M, which stands for density of mercury, times G. So we have finished our manometer. That means on this point, we're going to say equals to P2. The last what? Point is what? P2. But you must know that since P2 is exposed to atmosphere, that means P2 is the same as atmospheric what? Pressure, and is equal to 0. Why? Because it is what? Exposed. Because it's exposed to the atmosphere. So you must know that if point 2 is exposed to atmosphere, that means pressure at point 2 is equal to atmospheric what? Pressure, and is equal to what? To 0. Thank you very much for watching this video. See you next time for the next video.